So here's Miranda. Hey, how you doing?
Hello, good. How are you?
We're doing great.
All right.
So for those who don't know, or this is like one of the little known facts, right? Miranda and I actually are less than 2 miles from one another. So I'm looking out my window, and her house is over three hills in the town nearby. So I've known Miranda for a number of years. Had the pleasure of working with her. This is now the second time. I've known her family and just all around excellent people. Other quick fun fact, I also hired her husband at another company, which was another bonus. They're just amazing people, super smart. And I
We
love
just
her.
we
What's
we
that?
also just follow you around
Maybe
apparently.
that's it. No, I love, your energy in just exploring this data and wanting to show how to use fun, tooling that we're doing, ways to improve process. It's just been really cool. It's been cool to watch you learn, even in the database space, which has been newer for you. So what Miranda's going to talk about, which I think we'll get the little thing on the bottom here, we're always looking for data, right? And David, who you heard from earlier, back in like June maybe or end of May, was like, hey, the NFL released this really cool data set. Maybe we could do something with it. And so you had just started, and it was really fun to play with this and just seeing all the things we could do. And there's actually more content we're probably going to create soon. But I'd love to see you recap it, kind of what you did do and some of the ways you explored it. It's not a standard time series data set, right? So
Yeah,
we
it
all
is
kind of went,
not.
well, how do we analyze this? And it was really fun to see that process. So walk us through it.
Yeah, so as Ryan, yeah, I'm a developer advocate. My name is Miranda Auhl. So first off, I want you all to drop in the chat the first word that comes to mind when you hear the NFL or the National Football League. First word that comes to mind, put in the chat. I know you're watching. 41 of you. Anyone? First word that comes to mind? No? Ryan, what's the first word that comes to your mind?
I was going
Maybe
to say, I don't have a chat I can put it in. First that comes to mind is Steelers, I guess. I don't know.
Steelers.
We're
I
in
mean,
Pennsylvania,
we're
folks.
close to
Sorry.
Pittsburgh. We're close to Pittsburgh. Well, if anyone thinks of a something to drop into the chat, anything. Well, oh, touchdown! Thank you.
Good.
Yes,
I like it.
participation. Yeah. There we go. Keep it coming, guys. So the first word that recently has been coming to my mind is time series, and I am counting that as one word, so don't judge me too harshly. And you might be asking why. So I want to look at these three questions today, and that is NFL data time series data? Question mark. If so, so what? Do we analyze it? Can we analyze it? And if we do analyze it, how best do we go about doing that? So at Timescale, we have a motto, and that is that time series data is everywhere. And that includes, drumroll, professional sports. So historically, right, all sports have some kind of time series data, scoring points over time. I mean, it's not very interesting in its basis, but more recently, many professional leagues and the NFL in particular have started recording some very interesting time series data. In 2015, the NFL officially started requiring that all players and the ball have RFID tags, and that every single venue where a game is played has to have RFID receivers. Okay, so this means that since 2015, the NFL has been recording all the players and the ball's movement, acceleration, location, and beyond for every 10th of a second, which I will show you, for every single game. That is a lot of data, and it's time series data. And of course, yeah, with great time series data comes great responsibility to analyze it. That's how the saying goes, right? It's not how the saying goes, but I'm going to roll with it. So this is time series data, and if you have access to it, you can get so much power analyzing it, right? That's why we record data, is to make predictions, show visualizations, try and understand why something happened, or predict, in the future to prevent something. This is why we record and store data, is for analysis, really. And of course, the NFL, because data analysis is powerful and data in general is very powerful. The NFL has historically been very protective over this really cool tracking data set until 2020. So in 2020, the NFL began running these big data bowl competitions through Kaggle. And so it now is actually on its third year of doing these competitions. So the 2022 competition just started about a few months ago or something. And essentially in each of these competitions, the NFL has released like a good portion of this tracking data that you can download and play with for free. If you have a Kaggle account, you can download the data today if you wanted and play around with it. Like that blew our minds here at Timescale. Like Ryan said, like when David, we were like, oh my gosh, we can't pass up, pun intended, the opportunity to play around with this data. It's super cool. Yeah. So of course, here at Timescale, we believe with time series data, why not use a time series specific database? Now, as a Timescale employee, I understand that I am biased towards our database. I think it's awesome. But truthfully and honestly speaking, I really believe in and love the analytical functionality that TimescaleDB and Postgres gives its users. I come, as Ryan mentioned before, I come from actually a mathematical and more data analytics background. And so as I've kind of like been playing around more and more with TimescaleDB and Postgres, I was honestly blown away with how much I could do in my database rather than bringing it into Python or R. And a lot of that is really based in our continuous aggregates and our hyperfunctions and just being able to really use and manipulate them. I mean, if you were here earlier for David's talk, you saw how he was able to use some of the hyperfunctions to downsample data and, get a lot of value out of it was API calls. That's what it was. API calls. I mean, that is super cool, right? So now I could talk about this and, tell you how much I love the functions, but I'm a believer in let's actually see it in action. So I'm jumping over to DBeaver. DBeaver is an awesome UI tool that I like to use when doing analysis. It's basically, it just does the same thing that you would do in like in your terminal, but it makes it a little bit more like usable, I think. And again, if you like the terminal, stick with the terminal, you do you. So this data set that we are looking at here is actually the tracking data from the 2021 competition. And it specifies passing play data for the 2018 NFL season. Okay. Right. And so this column, I'll just briefly show you. So here is a set, right? This is all individual readings for, unique individuals or the football. If you notice this null here, the player ID where it's null, that's just the football. So we see these readings in 1/10 of a second increments. So we go 0.6 to 0.7 to 0.8 to 0.9 and then over. So this is data recorded at 1/10 of a second, for the entire game, every game in the season. That is crazy cool and a lot of data. And it's very granular, right? 1/10 of a second. That's super small.
So I think that just really quickly, the data that we found for the 2021, this one, so it's the 2018 data, and it's only passing plays.
Yes.
And that for the full season of 13 games or something was, 20 some million rows of data.
Yeah.
Something like that. So it's
solidly in the
bit
millions.
of it, right? There's a lot of data to track it.
Yeah, and it's really awesome. So in addition to time, of course, we have X and Y coordinates. And so this is actually what allows you to see where an individual or the football is at any given time on the field. So actually, if you pop back over to my PowerPoint, I can just show you real quick. This is an image of the field that they provide in the Kaggle competition, just explaining kind of how they set up the X and Y coordinate plane that they're referring to in these X and Y columns. So long end is X, short end is Y with the home and visitor end zones as such. You can go back to DBeaver. So, right, we have these columns, which in itself would be super cool to analyze, right? Looking at the movements, you could even track them, do an animation. And so then we also have speed, acceleration, distance traveled since the last moment in time, orientation, and direction. And then a bunch of like additional other stuff. We need the player ID to know who, of course, is, to what data source, that's important. Jersey number, position, all this fun stuff. Even play ID, they have a play table. So you could really look at individual plays if you want to. There's so many things that you could do, even with just this like pared down play-by-play data set. And it's super cool. Now, for me, whenever I approach an analysis situation, I first like to get kind of general trends and then kind of use those general trends to dive into like, okay, maybe I want to know who is running the most during a game so that I can look at, the plays that they're involved in, or maybe that individual, how they played during the entire game. So what I want to show is how I used continuous aggregates and hyperfunctions to kind of figure out these trends, these more general trends. And again, this can be applied our hyperfunctions can be applied in, the more granular ways. But of course, I don't have time to show you that today, unfortunately. So first off, let's hop on over to here. So this is a continuous aggregate that I actually already ran this, but I wanted to show you how I created it. And if you are unfamiliar with continuous aggregates, definitely check out the link that we have showing. We have lots of great information. If you want to get started with continuous aggregates, you could think of them as very similar to Postgres materialized views, but with superpowers, as I like to think of them. And essentially, right, it's pre-aggregating data that I might want to query from. So that I can query from it much faster and more efficiently than aggregating the data at real time, from the raw data. So that's really where continuous aggregates are really powerful, is if you need to be accessing aggregated data again and again and again, right? And so that's something that I do want to do. So I wanted to create this continuous aggregate. So my goal with this continuous aggregate, or CAG for short, we sometimes call it, is to find unique player IDs for one specific game and knowing the sum of the distance traveled, because I want to know the players that ran the most, because maybe I want to analyze kind of their movement. Okay.
Right.
So I need to identify them, and I can't identify them unless I know that. So here I'm setting up this select statement is kind of identifying the aggregate. So I have my player ID and game ID specified. I added position and team just in case if I want to get that info as well. But this is kind of like the beef of the continuous aggregate, right? We have very granular 10th of a second data, and I want to take the sum of it across a game, which I'm making the guess that it is over one single day. So I'm bucketing all the granular data summing it into 1 day's period for each individual for each game. Right. So that's kind of what this is doing, right? I'm bucketing it by a day, and I'm taking the sum of the distance traveled over that entire day. Okay. Now I will show you what this aggregate, and mind you, I just selected all of that aggregated data from my continuous aggregate. Notice how fast it is. You can just keep doing it again and again. Crazy fast, 40 milliseconds. That's awesome. And that's the power of continuous aggregates, really. And so as you can see here, right, I'll pull this up a little bit. So I have my player ID, my game ID, my position, the team specification, whether they're home or away, and then the bucket, right, this is bucketed by day, and then the sum of the yards. Now, right off the bat, I look at this, and the sum is it's kind of all over the place, right? We have 500, 13, 600. So again, I don't have a good feel of what is the range of typical summed distances that these people are running, right? I can't tell unless I look kind of at the statistics, the spread of the data, and I can do that using our hyperfunctions, which is really cool. Woo, hyperfunctions. I seriously love our hyperfunctions, not gonna lie. Fangirl right here. So my initial continuous aggregate, and this is the caveat of working with kind of irregular time series data. And that is that sometimes, our assumptions aren't necessarily true. So I made the guess that one game is played over one day. Well, it turns out that the tracking data, this time column, is actually taking, it's recording time in UTC, is the time zone. And so, which is 5 hours ahead of Eastern Standard Time. So if a game is being played in the evening of Eastern Standard Time, it could come across that it is played across 2 days. And so just to mitigate this issue, I'm using PostgreSQL. So that's what this little with some yards as. So I'm essentially doing this pre-query, which just now I know for sure I'm going to have this summed yards for one player of a specific, for a specific game. So that's kind of just what this additional query is allowing me to have confidence in. And then I can use that to query my hyperfunctions. So I will make this a little bit bigger because I only actually get one row out of this one. So I'm going to run this. Oh, sometimes it does this. Oh. Define parameter. Well, this is strange. This just worked. What am I doing? What is going on?
It looks like, is that the...
Oh, it's... Huh?
So here's what I think happened. I think you got upgraded. We released 2.5 this morning. I wonder if you got upgraded in the middle.
Oh.
And so you might have to recreate the aggregate.
Okay. Well, there we go. Unexpectedness.
That's my quick guess. I can't quite see the error message on the screen. I could make this bigger. I don't know why I didn't do
that. When you get upgraded in the middle of a session, that's fun.
So it's good quick moment to say, that's David mentioned. We're doing many of these things in experimental features first, which give you the opportunity to use them, play with them, think about what the value is. But, we say this in documentation elsewhere. It also means that, so we are always including this in Timescale Cloud. You're always getting the newest features when your upgrade period comes. And in some of those cases, when a experimental feature is redone, we basically can't guarantee that it's compatible. We may have made changes in that function that's compatible with the continuous aggregate. And so when you go to run the function again, we need to make sure that we have the right stuff there.
Yeah, essentially. Yeah. I'll just show you the code first, and then we will, again, we have a lot of really cool tutorials and actually Twitch streams on doing these exact, exact queries. So you can look them up, and it's even more information if you want to look into them. But essentially, right, when I would run this, when I'm not, upgraded unexpectedly, essentially what this hyperfunction does, and this is kind of why I, again, am really love the hyperfunctions that we created, is that a lot of them we created to be 2-step aggregates. And that's kind of pulling inspiration from how Postgres created some of their functionality. And we actually have a great blog post on hyperfunctions and the 2-step aggregate nature of them, and how they just kind of cut out recalculations that might happen again and again in a single query. Like here, if you notice, I'm running the same function again and again, but there's actually the heavy lifting percentile ag is only calculated one time for all of these different, function objects. And so it cuts down on time. It makes it far more efficient, which is really, really cool. And I'm able to get, the first percentile all the way to the 99th percentile of information on, this like continuous aggregate that I had. So then the last one that I wanted to show is this, and David actually showed some of it before, but it's the stats_agg, which is a newer function which we upgraded from experimental to kind of full-fledged hyperfunction like status. But essentially it gives you even more power. You can find standard deviation and you can get variance. And it actually, it even works for 2 variables. So you can get even X, Y standard deviations and like slope. It's crazy how much functionality that we are adding continually in these hyperfunctions, which is really exciting. And I think is just going to change.
No, I was going to say, I just recommend. I think your point is straight on when it comes. And someone, Raj, thanks for your exclamation with us. 2-step aggregates. The blog post, which I actually don't know if we have the URL to pull up or not. Yes, we do. 2-step API. This was an excellent blog post, and honestly, it was about Postgres. Like it's about how we use it, but it's about here's how Postgres works, and here's how the functions you're using all the time work, and allowed us to do something really cool.
Yeah, it's I definitely like the more that I'm seeing us adding these like hyper functions, and the team that works on this is called the Toolkit team. And what's really cool is that they have so many more ideas that they're actually adding and working on in the experimental side of things. And so if there are functionality, like if there's functionality that you think would be valuable, like for example, I know that I often will look or use skew and kurtosis whenever I want to analyze the distribution of data. And so I brought that up to our Toolkit team, and they're actually, they're implementing it right now in experimental. And so if you have like ideas on functions that you think would be really valuable that you could use in your analysis, tell us, let us know, put it in Slack, put it in GitHub. And because we want to continue building up functionality to help users, do the best work that they can do, and as efficiently as they possibly can.
Absolutely. Yeah, it's great. So yeah, that's a great point. Any of these tools. So a lot of what Miranda was showing, number one, there's a blog post on analyzing NFL data. There's a tutorial that we already have on taking this data set. We show you how to get the data, how to load it. It's on the screen now. So please go look at doing that. And we've been having conversations with some people in the community about how to do even more things with this data. And so I know Miranda and I just really want to get back to that. So hopefully in the next month or so, we might even show you things like how to use that XY coordinate within Postgres as geospatial data and plotting things on a map, which is really cool. I loved how we had this data, and you were asking as we were getting ready for the blog post, like, is there a place someone wants to like find and we can map this out? You did in that blog post showing how to do it in Python. And I love Prashant was like, oh yeah, this game from 2018, let's go. And it was so cool to see. And you're like, this is all happening in Postgres. This is really fun. So
it's very cool. Yeah. Does anyone have any questions?
Yeah, any questions? Please feel free to put in chat, Twitch or YouTube.
Oh, and I do have a slide of resources if anyone wants to snap a picture.
Yeah, go for it.
Here's my, it's just like resources of things that I talked about. Yeah.
Great stuff.
Yeah. Looks like we don't have any questions.
Well, there you go. That's maybe time series data that people wouldn't necessarily think about as time series data. Earlier, Rory Kazakh on Twitch said, hey, in my opinion, all data is time series component. It's really just a matter of whether or not people are tracking it. And we couldn't agree more. There's so much potential value there. And, not where you always expect it. Data that's a week apart for a team, right? But it's still in that moment. And what you need to see is still time series.
Yeah.
Cool. All right. I think we're going to go ahead and take a 5-minute break here. We've had to skip a few because we just have such good content. But we're going to take a break. Miranda's going to come back with our next guest. And someone just asked, will you be able to rewatch these? Absolutely. We are going to be posting either the whole thing or we might break up the individual talks just from Timescale Day, Community Day. So keep an eye out on socials for where those things land, but it will be on YouTube later after the fact. All right, so let's take 5 minutes, get a cup of coffee. I need to go get a new cup of coffee myself.
Yeah.
And Miranda will come back with our next guest, which is Mario, to talk about how he's using time series data in Timescale.
It's very exciting.